students, welcome to Easy BTech, your guide for BTech and beyond. Easy BTech YouTube channel helps the students to prepare well different engineering subjects and score very good marks in the examinations. It also helps the students to understand the concepts easily, and also it is useful for the competitive examinations as well as the placement drives. In the previous video, I explained you the concepts of engineering mechanics and force systems. I am Chari. Today, I discuss about resultant of a force system. What is meant by resultant? Resultant means it is a single force which produces the same effect as that of number of forces acting on a body. It means, let us say, if more number of forces are acting at this point, F1, and let us say this is F2, and this is F3, and let us say there is one more force F4, and this is F5. Let us say this is at an angle theta. So if you have taken a force system, if you replace it by a single force, then it is known as the resultant. And if you give this value, so this is magnitude of the resultant, and if you also mention the direction, angle, then it is a direction of the resultant. So resultant means it is a single force which replaces the given system and which has got the same effect as that of number of forces acting on a body. So if all the forces are combined together to get a single force called resultant, then it is known as the composition of forces. It is known as composition of forces. And if a force is divided into its components, then it is known as the resolution of a force. The basic difference between the composition of force and resolution of a force is this. Composition means we are combining the force vectors to get the resultant, which is a single force. Resolution of a force means a force is divided into its components. Then it is known as a resolution of a force. It means the force can be resolved into its component, let us say Fx and Fy. So this is taken on xy plane. So when you're taking the two-dimensional one, F is divided into Fx and Fy. We're taking the three-dimensional one, so F is divided into Fx and Fy and Fz components. Resolution of a force is an important one in solving the problems of the resultant and equilibrium, friction, and also the various problems of dynamics. So the composition of a force gives the concept of resultant, and resolution of a force is useful in finding the components of a force. Now we discuss about parallelogram law of forces. Parallelogram law of forces is useful to find the resultant whenever the two forces are given with an included angle theta. Let us say there are two forces. So one is P and another one is Q. these two are inclined at an angle theta to each other, it is given. Parallelogram law of forces gives the magnitude and direction of the resultant. So if these two forces are taken as the two sides of a parallelogram, so we complete this construction, then the diagonal passing through the intersection of these two forces, let us say this is O, so this gives the magnitude of the resultant, and the angle made by the resultant with P, let us say this is pi, gives the direction. And what is meant by parallelogram law of forces here? If the given forces are represented as the sides of a parallelogram, and the parallelogram is constructed, then the diagonal passing through the intersection of these two forces represent the magnitude of the resultant, and angle made by the resultant with the P or Q gives the direction. So this can be done graphically in this way, and analytically R is equal to P square plus Q square plus 2PQ cos theta, where theta is the angle between these two forces. So this is the formula for the magnitude of the resultant. When it comes to the direction of resultant, tan pi is equal to Q sin theta by P plus Q cos theta. So this is an important one. Whenever two forces are given and with an included angle between them is given, the magnitude and direction of the resultant can be calculated by using these two formulae. Now we solve a problem based upon parallelogram law of forces. Two forces 10 Newton and 20 Newton are inclined at an angle of 45 degrees with each other. Find the magnitude and direction of the resultant. So here two forces are given. Values are 10 Newtons and 20 Newtons. And with an included angle is 45 degrees is given. So then we should apply parallelogram law of forces. So solution is P is equivalent to 10 Newtons and Q is equal to 20 Newtons and theta is 45 degrees. So this is the given data. So one is magnitude of resultant. So R is equal to P square plus Q square plus 2PQ cos theta. So this is the formula. So now you substitute the values 10 square plus 20 square plus 2 into 10 into 20 cos theta cos 45 degrees. So if you calculate this resultant value, it comes to 16.82 newtons. So Now you find direction of resultant. So this is given by tan pi is equal to q sine theta by p plus q cos theta. And substitute the values of p and q here. It's simple. So here this is 20 sine 45 degrees by 10 plus 20 cos theta. So cos 45 degrees. So when you do this direction of resultant, the tan pi value is equal to tan pi value is equal to 0.585 and pi is equal to tan inverse 0.585. And when you do this tan inverse 0.585, this comes to 30.32 degrees. So this is the solution. Once again, the two forces are 10 newtons and 20 newtons are inclined at an angle of 45 degrees with each other. Find the magnitude and direction of resultant. So whenever you come across the two forces and an angle, you remember, apply the parallelogram law of forces. R is equal to root over p square plus q square plus 2pq cos theta. And here substitute these values. And you get the resultant value 16.82 newtons, and then you go for the direction. So tan pi is equal to q sine theta p plus q cos theta. So then you get this is 30.32. So that means finally, so if you represent by a parallelogram like this, so this one is P is equal to 10 newtons is taken. This one is Q is equal to 20 newtons. And at the beginning, this angle is 45 degrees. And now this diagonal represent the resultant. And this resultant value is 16.82 newtons. And the angle made by this resultant with P is 30.32 degrees. So in the examination, so they may ask the inclination of the resultant either with P or Q. If it is asked for Q, so that value will be 45 minus 30.32 degrees. This is how you can solve the problem related to the parallelogram law of forces. I hope you understood this one. So in the next class, we discuss more problems on the parallelogram law of forces. Thank you.